Hi, everybody. So I hope the sound is okay on this one because I don't have my microphone, but hey, it is what it is, right? So chapter 14, this is just a review of chapter 14. This one should be pretty quick. Chapter 14 was talking about epidemiology. Epidemiology is basically studying disease, and it doesn't necessarily have to be infectious disease, but disease within certain populations and tracking them, and even trying to figure out solutions for whole populations in a community. So that's epidemiology. And in general, epidemiologists who are doing this, they are looking for the who, what, where, when, and whys of an outbreak or of an active infection. We did introduce Florence Nightingale, who was working during the Crimean War. Noticed that a lot of the soldiers were dying, was like 32 out of 100. And then she instituted some aseptic practices, basically cleaned up the, unsanitary practice of that hospital and reduced that down to 2 out of 100. So that's really great. Then we also have John Snow, who narrowed down a cholera outbreak to a specific well site. And when they removed the handle of the well to stop people from going over there and using it because they wouldn't listen, it helped, stifle the outbreak of cholera at the time. So that was, good news. So epidemiology, basically, here are some concepts that you might want to be familiar with. Prevalence versus incidence. Prevalence is essentially how common the disease is overall, over basically when you discovered it. And then we have incidence, which has to deal with how the frequency of the disease within a certain time period. That also relates to the morbidity rate dealing with, the presence of that illness in a specific time period that we're looking at. And we'll also usually compare that to the mortality rate during that time as well. Mortality rate, of course, being the people who had died from those illnesses. So next we have point source epidemic versus common source versus propagated. Point source epidemics, we have a single source from wherever it stemmed from, a single source, and everybody got sick at the same time. A common source epidemic is we have a single source still, but this one's over a certain period of time. So a while has passed over which these people have been exposed to whatever it is that led to the epidemic. And then a propagated epidemic is basically one that is being sustained by the population within that outbreak. So that's what we see a lot with the flu. I'm just passing it from person to person, and then that going on and being an ongoing thing for a while. Any disease that is endemic is one that is at a relatively steady rate in a certain locale. So whether a disease might be common in that particular location, and that specific amount of people being sick as well. So if a third of the population in that area tends to get sick over a year from whatever virus, then if we start having a lot more, about 30% of the population getting sick, then we would call that an epidemic, because that would exceed the prevalence of what is expected in the population, even for what is endemic. But that will also apply to any sporadic diseases, and sporadic is just something that comes up randomly in an area and doesn't persist for any given amount of time in that area. I always give the example of rabies, or like when we had Ebola, right? That was a pretty good example of that. So that's sporadic. And pandemic is whenever we have the spread of disease across continents. We know that from COVID. So there were screening tests that we can also use as diagnostic tests as well, but these will be basically assessed based on their specificity versus their sensitivity. For specificity, what it's referring to is it will be binding to the positives, but it won't be triggered by anything that is even slightly like the positives or whatever. It will only bind to the positives. However, some of the sometimes we'll get a negative test because the positives might be too few and far between to have caused it to trigger positive. So false negatives are actually more likely with the specificity ones, whereas with sensitivity based, we are talking about the false positives being more likely, because we're going to be binding to pretty much anything that there is in that testing. Anyways, we will conduct some studies to try to investigate the infection, maybe how common it is, or what is likely to have caused it, and everything like that to help us find this data. And we would do cross-sectional case control or cohort studies. Cross-sectional studies are going to collect data based on two factors, essentially, that will be collected at the same point in time. Whereas case control, we were going to be ask, essentially, if you have a group of people that have the condition and people that don't have the condition, and then we'll get details for each group and compare to one another to see if anything jumps out as different. And then cohort testing is going to monitor people that do not have the condition over time to look for any disease indicators, if they are going to acquire the disease as we're monitoring them over time. Next, we talked about keeping hospital or healthcare associated infections under control. And more or less just talking about, infection control officers and, using PPE and gloves and everything like that, and making sure we monitor the incidence of these illnesses that are likely to occur in healthcare associated situations to prevent them from popping up again and being an issue. R naught and case fatality rates. Case fatality rate is what it sounds like. We're going to be talking about the rate that you are likely to die, that people in a given set of group would be likely to die faced with this disease, right? So, of course, this would include something like Ebola, or that would be highly deadly. So that would be much more deadly than like the measles. However, when we talk about R naught, this is the number that is referring to if you have this disease, how many other people you are likely to infect because of the infectiousness of that disease. So highly infectious diseases would include the measles. Measles is not very deadly, but it has a really high R naught. You're likely to infect a lot of people if you do become ill with it. These are, of course, numbers that we're taking in situations for people that are not vaccinated or haven't been ill with the disease before. So, so those are the numbers we would be concerned about. Herd immunity is basically determined essentially by the R naught. It just depends on the pathogen that we're talking about, but herd immunity is whenever you have so many people that have immunity and are protected against the illness at hand, so many of them that because of how infectious that pathogen might be, the likelihood that we would be able to protect somebody who cannot be vaccinated or is not vaccinated based on having, whatever percent of the population protected. So, for example, if we have 95% of the population vaccinated against measles, then we can protect the other 5% of people. That's the minimum, is the 95% for measles. That's a real number. So that's the value in R naught and herd immunity when trying to eliminate diseases or protect people from diseases through vaccinating a population and maybe protecting people who aren't vaccinated for whatever reason. So COVID-19 vaccine development. It went through several stages of testing, and it did go through all of the testing stages, all of them. They pushed into the phase 3 testing before phase 2 was complete, but they still did actually complete all of the phases, and that's why they were able to push that vaccine out so quickly. It is an mRNA vaccine. It's a messenger RNA, to remind you guys that dealing with the genetics chapter. So that means that it is the mRNA, the actual active one, is going to be carrying the message for the protein. In this case, we're talking about a viral protein. So they inject it into your arm, your muscle tissue, your muscle cells will start producing the viral protein. Antibodies come and see that as foreign. So we'll start making antibodies against that viral protein that's just in your arm. And then next time that you see the virus, your body's like, I've already seen this, and it protects you. So that's the idea of how that is supposed to work. Emerging versus re-emerging diseases. Emerging diseases are new diseases, new to us. So we would even consider HIV relatively new. every time we have a new strain of flu come out, it's a new thing to us. So that would be an emerging disease. Literally, even though the flu seems like forever, each strain is new to us. So it is an emerging disease. Re-emerging diseases are diseases that we have seen in the past in history for mankind. And now we're seeing them come back out again due to whatever scenario, whether it is climate change or, urbanization or whatever. So, yeah, so those would be concerns. That even includes tuberculosis, where we have an increase in people who are having HIV now over time, of course. But HIV positive folks are more susceptible to catching tuberculosis and are maintaining it essentially in those sorts of communities. So that's one to be aware of. All right, finally, we had talked about neglected parasitic infections. One of the ones that we talked about was toxoplasmosis. If you guys weren't listening to the last lecture, Toxoplasma gondii is a protozoan that is maintained as in the reservoir of cats. Cats are the reservoir. So they maintain it, and mice can get infected and they will have slower reflexes, and they will be more likely to take risks. And so both of those benefit the cat when they are hunting the mice, but that also tends to have similar effects on human beings, they believe, which, you might think about how many decisions people have made, will infected with that. Yeah, so that's an interesting concept to think about. So toxoplasmosis, that's actually one that we do have here, a parasitic disease we do have here in America that is an issue. If you are pregnant, you do not want to handle cat litter. It is very dangerous to the fetus. That is the truth. So you don't want to end up having any birth defects or anything like that, problems with your pregnancy. Just make somebody else handle it. So yeah, that was it for chapter 14. And I will see you guys for the next one, I guess.